Hello, everybody. Welcome into the projectile motion lab. We tossed a ball in the air. We recorded it. We had a meter stick behind it. Great reference point. Put it in the tracker app. Found its position, its velocity. We created a script to simulate the motion, and we could add and remove like a drag variable. So we could see how drag affected projectile motion. We could see how all that worked. We could talk about things like terminal velocity and how like net force works with all that stuff. Very interesting. These are the equations we used. We got the position update formula, the velocity update, force of gravity, force of drag, and of course, F equals ma, our beloved. We got some wonderful pictures here to share with everybody. We had our ball as it's flying through the air with our tracker app. We have our code. We have the initial position. We set the initial position akin to the initial position of what's in the tracker app. I have yet to figure out how to set its initial position to 0, 0. Our TAs weren't being helpful. Well, I mean, it was a busy day. My mind was slow, but it was difficult. It was. Then we got our initial velocity. We have our put the delta time for our code the same as the delta time in the video, and we have our gravity constant and our drag constant. Then of course we had the rest of our code, which is we got like a unit vector, the speed, we found the net force, position update, velocity update, coding things. We printed position, time, and like each position y and x and time separately so that I could put them into the spreadsheet easier. And that was really nice. That was really easy to do it that way. It was very useful. But yeah, got our glow script up and running. Then we have our graphs that we made using our glow script data as well as our tracker data. It can be a little bit hard to see uh, each trial, some of them, but I promise all three are in each of these. They just overlap a lot. Now you'll notice that there's really not, the actual trial is really far away from the glow script ones. It could be closer, but that's when we talk about our error. So we have some tracker error. Clicking that ball with the different frame rates, the data, sometimes it smeared a lot. It was really difficult to keep that very consistent. And most importantly is the drag constant probably isn't correct. Once we were refining the drag constant, I didn't really find a clean way to find the drag constant, or my TA told me to just guess and check, and eventually it got close enough without being unreasonable and making the code kind of glitch out a little bit. So if we could find a more accurate drag constant, the graphs would line up more accurately. We had these important questions we needed to discuss. What happened? What does it mean? Terminal velocity, right? Right. Did we reach terminal velocity in anything we did today? No, we did not reach terminal velocity in both the mathematical and the physical. We could reach terminal velocity if we increased the total height it was allowed to fall, thus allowing it to reach that point, but it simply wasn't tall enough to do that. And then we had what happens if our object was thrown straight up. If it was thrown straight up, it would take much longer to reach the ground because all the velocity that went into the x-axis is now in the y, which means it would take longer for the velocity to hit 0 and then start being negative, okay, going down, and then it would take longer thus to reach the ground at all. It would reach the ground at a higher velocity, which is interesting, though it is not what the question is asking. All right, thank you guys.